Hi everyone. Today we're going to learn how to study frequencies, and notably we're going to perform a chi-square independence test. There's already a video on how to do chi-square independence test, but in this video I wanted to address how we can do that by plugging in directly in SPSS what we have here, which is what is called a contingency table. So this contingency table includes the different observed frequencies. Here we have frequencies for gender and cross-tabulated with handedness. So we have 12 right-handed males, 17 right-handed females, 8 left-handed males, and 3 left-handed females. And our objective here in this data set and in this analysis is to know whether or not gender is significantly related to handedness, right? Of course, this is all just fictional data, right? So I will just open SPSS. Wait a bit. So I'm going to keep this table over here. I'll just start a brand new data set. Okay. Right. So this is the output. Sorry. Let me see the data set here. Okay. Interesting. Okay. So here's my data set, contains nothing, no unit, no variable. So I'm just going to first create two variables, one for handedness and one for gender. Right, so the first one will be called handedness. Right. The second one will be called gender. So if I look here at the properties, I am here, handedness and gender should actually be two factor variables or string variables, but the important thing here is that the level of measurement should be nominal, right? So to facilitate things, I'm going to select a string type of variable. It will also work with a numeric variable, but you see here it has automatically switched my measurement type to nominal. I could also have used numeric type of variable, but I've changed here. You can see scale, because here I cannot be a scale. But here, for example, if I kept numeric, right, I would have started with the scale option, but I would have to switch it to nominal. So I'm just going to use string. It'll just be quicker here. I'll not write a label, but we could. Here it's just one word, so that's okay. So what I'm going to do here is, so I'm switching back to the variable view. I have these two new variables. So one thing I could do to do this chi-square analysis is I could create or I could report each participant in the study. Right? For example, I could say that participant 1, right, is right-handed and is a male, right? And I would have to add 12 of these, right? So I could write right, male, etc. And so I could copy that, right? Oh, doesn't work. Could copy that, right, 12 times, right, for 12 units. And then, right, so same thing here, male. So I'm pasting, right? Right, and then I would switch, for example, to the 8 left-handed males, etc., right, 8 times. And of course, same thing then for female. But that's a bit long, especially if you start from a contingency table with thousands of participants, right? Here it's still feasible, but if you have thousands of participants, that may not be. It might also be, if you have thousands of participants, that you already have the data set this way, right? It doesn't need to be in this order or in any order, but if you have all the units, right, as different rows, of course you can directly perform the analysis. But in some cases, you will be faced directly with this contingency table, right, and not the raw data set that has produced this table, right, but directly with the counts. So when you're in the situation and you have a large data set, you don't want to do that, right, because that would be very long, not very time efficient, right? So I'm just going to clear that. Yes, all the cases removed. So I'm going to clear that, and I'm going to do things differently, right? Because there's a more efficient way of doing that. We are actually here only going to create units for all the 4 possibilities, right? This one, this one, this one, and this one. So in other terms, I'm going to create here right-handed, left-handed, and that's going to be for male. And I'm going to create right-handed females and left-handed female. Right, so here we have all 4 possibilities: right-handed male, left-handed male, right-handed female, left-handed female. The problem is, of course, that SPSS knows what the different categories are, but SPSS does not know how many people are in which category. And so we are going to sort of trick SPSS here by creating a variable that is going to weight these different categories. Right, so very originally we're going to create that variable under the name weight, right, and we are going to weight each of the categories. Right, so here that is going to be numeric because we are going to directly use these frequencies, so it will not be a category. So let's select scale here, right? Check that you have scale for weight variable. We don't really need decimals, right? So I'm just going to, because we have entire counts here, frequencies, so we don't need decimals, and that's it, right? So the next thing that we will do is go back to the data view, and you see we have this new weight variable that's been created. The only thing that we need to do now is to plug in the numbers. So we have 12 right-handed males, 8 left-handed males, 17 right-handed females, and 3 left-handed females. All right, so 12, 8, 17, 3. All right, so we have everything we need. We sort of reproduce this data set, except we change the weights presented, but that's it, right? And so the next thing we're going to do is we're going to tell SPSS to weight all of these units by this new weight variable that we created. And how do we do that? So we're going to click on Data, in the Data menu, and right at the bottom we have this menu that offers to weight the cases. That's what we are going to do. I'm going to weight the cases. Right. So it's pretty straightforward. Of course, the default option is to not weight the cases, but here what we want to do is weight the cases. So we'll click here on Weight Cases By. We'll select Weight. That's actually the only scale variable. Right? That's only the only internal variable here, interval variable here. So that's the only one that we can use anyway. And we're going to click here, and so now we have weight here, and we can directly weight the cases. Just need to click OK. Right. So we have weighted by weight. Right. So back here on the data view, we have everything we need to do our chi-square now. So we'll use essentially the same menu as before. So let's click on Analyze, Descriptive Statistics, cross tabs. And so Analyze, Descriptive Statistics, cross tabs. Let's click here. Okay, so we have here rows and columns. So it doesn't really matter which one we put in rows and which one we put in columns, but we have these two variables that we want to cross tabulate. And the weight, we leave that alone because the cases are already weighted here. We're going to click on Statistics, to select which type of statistics we want, and obviously the one we want is the chi-square statistic. Also, we have learned that it is often useful to report effect size, and one of the measures of effect size is commonly used for contingency tables and for independence tests is Cramer's V. So if we click here, we will have Cramer's V, and we can directly click on continue. You have, of course, other options to report percentages, and etc. Okay, so that's it. The only thing we need to do now is click OK. Right, so here what we have is the table that we actually have here, right? Except it's not ordered in the same way. We have left here over right and female before male. It's because it is just sorted alphabetically. But it's the same table, right, with the same data. So now if we have a look at the chi-square, we have a chi-square value of 3.13. If you remember from the course, that's a value we had with the same data. And a p-value here of 0.077. If you also remember from the course, it's actually the value that we had, right? So it's perfectly consistent with what we previously had. Now if I scroll down and have a look at Cramer's V, we have a Cramer's V of 0.28, which is also consistent with what we had in class. Right, so that's it. That's not more complicated than that. This type of analysis is especially useful, and it's especially useful to know how to weight the cases like that, once again, when you start from directly contingency tables like that. But note that you don't necessarily need to build the contingency table, especially if you already have the raw data set, right? You don't need to weight the cases if you already have all the cases row by row, right? But in some cases, you will be faced with these situations where the data has already been processed a bit, like here in a contingency table. Right, hope it helped, and see you in the next video.